Hey, what's going on, guys? Let's do this problem right here. The first question is asking, when a rocket traveling toward a mountain at 100 meters per second, the sound waves from the rocket engine approach the mountain at speed v. If the rocket doubles the speed to 200 meters per second, the sound waves from the engine will be now approach with the mountain at speed. So if the speed of the rocket changes, what happened to the sound? The sound velocity never changes, right? It is not depends on the source speed. So even if the rocket speed changes, sound is gonna be still traveling with the same speed because it depends on the medium. Because in the air, the sound is gonna be always in the certain speed, and if it's like a solid, then the speed will increase. But since the medium is not affected, density of the things is like density of the air is not affected, the sound is not going to be affected, so velocity of the sound is not going to be affected too, right? Therefore the answer for this question is v. The velocity is going to be still be v. That's going to be the velocity of the sound. Let's do this next question. That is an enclosed chamber with sound absorbing walls has a 2 meter times 1 meter opening for an outside window. A loudspeaker is located outdoors 75 meters away and facing the window. The intensity level of the sound entering the window space from the loudspeaker is 80 decibel. Assume the acoustic output of the loudspeaker is uniform in all directions, and that is acoustic energy incident upon the ground is completely absorbed and therefore is not reflected into the window. The threshold of hearing is 1 times 10 to the power of minus 12 watts per meter square. The acoustic power entering through the window space is, so they are asking for the acoustic power, and they have given this one. This is basically 0 decibel, and then they have say the loudspeaker intensity is 80 decibel, right? So first of all, before to do this one, we have to find the power. We know the equation for the power is I is equal to P over A. Therefore, P is going to be equal to I times A. We know the area, that is 2 times 1 right here. This is our area, but we have to find the intensity. That's given in decibel, but we have to convert into watts per meter square, because if you look at this is meter square. If I convert this into my watts per meter square, then only that will cancel each other, right? So let's convert this one into watts per meter square. That's really not hard as you think, because each power of this one increase 10 decibel increases. Like for example, this is 0 decibel, right? If I increase this one by 1 power, if it's minus 11, this is going to be 10 decibel. So if I want to get 80 decibel, I have to increase this power by 8 power. So if I add 8 more power, what's going to happen to this value? This will become 1 times 10 to the power of minus 4 watts per meter square, right? So that's going to be the intensity the loudspeaker producing. So here we can write 1 times 10 to the power of minus 4 watts per meter square, and this is the intensity of the loudspeaker. And then we have to multiply this one by the area, that is 2 times 1, that's going to be 2 meters square. So if I multiply this one by 2, that's going to be 2 meters square, and that the whole thing will become 2 times 10 to the power of minus 4 watts, right? So this is in watts. Now if I want to convert this one into microwatts, I can add 2 more zeros, and that's going to be micro, because micro is 10 to the power of minus 6, so this is going to become 200 microwatts, and that is the power. That is the acoustic power entering through the window, and that's the answer for this question, right? Let's do the next question. The next question is asking, a howler monkey is loudest land animal and under some circumstances can be heard up to distance 5 km. Assume the acoustic output of the howler to be uniform in all directions, that the threshold of hearing is 1 times 10 to the power of minus 12 watts per meter square. The acoustic power emitted by the howler is closest to. So they are asking the same thing. What is the acoustic power emitted by the howler, right? Howler monkey. So we can use the same equation. I is equal to P over A. P is equal to I times A. And then intensity. They have provided the intensity already, so that's not a problem. So 1 times 10 to the power of minus 12 watts per meter square. And now we have to find the area. Now what area we have to find? Because in this case we have to think about how the sound waves will travel in the atmosphere, right? So whenever you see the sound wave is going to be always traveling in the sphere shape. So this is we have to apply area of the sphere shape. So area of the sphere shape can be calculated by using 4 pi r square. So here the radius is provided 5 kilometer. So first of all, before I do that, I have to convert this one into meter, and this is going to be 5,000 meter. 5,000 meters, then 4 times 5 times 5,000 meters square, and that's going to give us 25 million, right? Because 1,000 that's going to be million. So 25 million, 45 times 25 times 10 to the power of 6. Then if I multiply 25 times 4, that's going to be 100. So we get 100. This is going to be 100. 5 times 10 to the power of 6. And here we have, this is meter square. And here we have 10 to the power of minus 12, 10 to the power of 6. If we add them together, we get 10 to the power of minus 6. And this is going to be 105, 10 to the power of minus 6 watts. And if I want to convert into milliwatts, I can simply multiply this one. If I multiply this one, 2 powers will go away because it's 100, right? So it's going to be minus 4. But if I want to, so this is going to be 1 times 5 times 10 to the power of minus 4 watts. And if I want to convert into milliwatts, I have to divide it by 10. So this is going to be 0.1 times 10 to the power of minus 3. That's going to be 5 milliwatts. And that's how we find these kind of answers. I hope you guys like this video. See you next time.